Here a node be there. Suppose if someone is asking that instead of two parallel plates, if there will be three parallel plates and all plates having different charges, then how you can distribute the charge on the faces of the plates as well as the capacitors between the plates. So see, note, if instead of two parallel plates there will be three parallel plates and all plates having different charges on it of negligible thickness. Then see, there is three parallel plates. Suppose the charge is on one plate PQ1, now second PQ2, and on third PQ3. I want to find the charges on the left and right face of first plate, again on left and right on second, and on the left and right on the third plate. So you just named it. Suppose this one is plate 1, plate 2, and this one is plate 3. Suppose this plate face be named as A, this one is B, C, D, E and F. So I want to find Q1A. So charge on A directly, see, using the previous concept, here we will get direct the charge on face A using the previous concept. How's? Very simple concept. If you wanted to find QA, charge Q1 is distributed on both of the faces as well as Q2 on both of the faces, Q3 on both of the faces. Whenever you will consider this face A, so your charge will be here Q1 by 2, because same charge distributed on two faces, but you are going to be considered on one face. So it is on one face out of two, so that will be Q1 by 2. Same in this case, there is Q2 by 2 here, Q2 by 2 here. This one is same by Q3 by 2, Q3 by 2. That is altogether Q3, altogether Q2, altogether Q1. What happening? Due to this charge distribution, the electric field at this place, due to this one in this direction, due to this one in this direction. So here you are getting due to charge Q3 is also in this direction. So Q1 by 2, Q2 by 2 and Q3 by 2. So your Q wave will be directly charge on faces A, B, C, D, E and F. Using previous concept, using previous concept, that is QA, directly use the concept of electric field and the distribution of charge, that is directly Q1 plus Q2 plus Q3 divided by 2. This one is equation 1. If you wanted to find charge at this phase, then your QB, see here, you have to take in this direction. Q on this phase B, your electric field lines be in this direction. For this one, your electric field lines will be in this direction. So you supposed to be this one is EA, and you just say this one is EB. So accordingly, you have to take this one as a priority. That is EB as a priority. So you have to take all electric field lines in this direction. But here you will get by this phase in this direction, so that will be negative. So here you can see that EC in this direction. Accordingly, by this phase EE in this direction. So accordingly you have to take negative and positive. So EC, that is negative for this reference EB, EE will be negative for this reference EB. So what happens? Your Q1 by B, Q1 by 2 will be positive, whether Q2 by 2, Q3 by 2 will be negative. Therefore your QB will be, directly here you can write down that Q1 minus Q2 minus Q3 divided by 2. This is your second equation. Now again you want to find charge on this phase C. So here you can see that C is in this direction by electric field. Now EE is in this direction, but your EB is in this direction. But because your getting your charge on this phase C, so you have to take this direction, left direction, that will be as priority. So your this one will be negative. So you just write down your QC, that will be Q2 plus Q3 minus Q1 and divided by 2. Direct method. But keeping all concept in your mind. Okay, now again you want to find on D. So due to this one charge Q2, your ED in right direction. So except right, see EE is in left direction and EB is in right direction. So here you want to find charge on phase D, that is you have to take the charge in the direction of electric field in this phase as a positive. So see, Q2 will be positive, QA will be positive, but Q3 will be negative. Therefore, your QD will be Q1 plus Q2 minus Q3 divided by 2. Equation 4. Now you have to find QE. Then QE, your electric field is in left direction, so all charges you have to take as a electric field direction in this direction, that will be positive, and opposite direction, that will be negative. So this one is in Q3 will be considered as positive, whereas Q2 for this case, this one is negative, and Q1 for this case, this one is also. Q1 minus Q2 by 2. This is your equation 5. Similarly, you have to find QF. Now see the direction of electric field lines. At this phase, your field lines by this charge in this direction, EF. So what happens? This one is left to right, you have to take positive. So Q3 is positive, right now QD, where Q2 is also positive, and Q1 due to E is also positive. So every charge is positive right now. Therefore, your QF, that will be Q1 by RG plus Q2 plus Q3 divided by 2. Equation 6. Consequently, what you are saying? You are saying that QA and QF both are equal. That is, charges on the left face of first plate and on the right face of the last plate will be equal. Whereas now you see the rest of the charges here, here, here and here. So what you see that the charges on the right of first and left of second is equal and opposite. That is this one and this one. You can say these two charges, that is B, QB and QC, are equal but opposite. Whenever you will take a negative sign here outside from this equation, then you will get Q1 will be positive and these both are negative. So you will get the same charge but opposite in nature. As well as the charges in between the plate 2 and 3, you will get same charge but opposite in nature. You can say Q1 plus Q2 minus Q3, and here is whenever you will get negative outside, so same you will get Q1 plus Q2 minus Q3. So consequently, consequently, uh, QA is equal to QF and QB is equal to negative of QC. Now QD is equal to negative of QE. So this is your resultant. Again, using the concept, if you wanted to find the capacitance between these two plates, so you will get two capacitors. One capacitance between plate 1 and 2, and another one between two capacitor parallel plate 2 and 3. So to find the capacitance between these three parallel plate capacitor, first of all you have to see what is the separation between them. So if the separation between the plates are equal, that is D and D, so we just find out first of all the resultant field lines between these two plates, and then again between these two plates. So whenever you will use this one, then in same manner you will get the field lines between the plate 1 and 2. You will get field lines, electric field between plates first and second. Now electric field between plates 1 and 2, that would be now here we are going directly because we have previously we have learned that how it's coming by one phase on this parallel plate and by this phase on this parallel plate. This one is U is supposed to be, this one is EB, so this one is epsilon naught sigma by 2 epsilon naught, and if you find EC, then that would be also sigma by 2 epsilon, but that would be negative. But resultant, whenever you will get resultant, then your resultant E, that would be sigma by epsilon naught. Similarly, in between plate 2 and 3, it would be also sigma by epsilon naught. So just I am going to put directly that your E, that would be sigma by epsilon naught. So you just supposed to be, this one is your equation 7, and then you have to find potential between this plate 1 and 2. So your potential, that would be P is equal to E D. So you just put your value, you put the value E D sigma D by epsilon naught. So this one is your resultant, and this one is your equation 8. And then you have to find capacitor. So I am just going to very directly, because we have learned all these consequently in previously. So therefore, your this capacitance, that would be Q by V. How much is your Q? Actually your Q is either QB or QC. So you just take QB, where your QB is Q1, QB is your Q1 minus Q2 minus Q3 by 2. So you just take it as, and then V, so your V from this equation, sigma D by epsilon naught. So directly QB, just keep in mind QB, and denominator of denominator, this comes in numerator epsilon naught by sigma D, and then put the value of this sigma. So finally you see that will be QB epsilon naught, put the value of this sigma, surface charge density. Your surface charge density is QB by A. So this one is QB by A, and then D. So what happens here? QB will be cancelled. So finally your capacitance, that is denominator of denominator, comes in numerator epsilon naught A by D. So from here you got, from this equation 9, how much is this? This one is capacitance between plate 1 and 2. So you can put there C12. So your C1 to be this much. Similarly, if you wanted to find the capacitance between plate 2 and 3. So similarly, C23, I am just going to get it directly. That would be also QB, QC epsilon naught divided by QC by A into D. So from here QC will be cancelled, because everything will be same. Epsilon naught D, that D is the separation between the plates 2 and 3. Therefore everything will be same. The difference is only in its charge. So charge is replaced by QC in place of QB. So what happens? You will get same thing, epsilon naught A by D, and this one is your capacitance between the plates second and third. So from here you can see that you are getting the same result, epsilon naught A by D, like that. This one is your equation 9, and this one is your equation 10. So the capacitance between plate 1 and 2, C12, and this one is C23, and both are equal, that is C and C, and this is the result. So from here, from equation 9 and 10, from here you will get that C12 is equal to C23 is equal to C, and there is a relation in between C12 and C23. We will discuss in next class about the relation, that how it is related, both of the capacitors using these three parallel plate capacitors, and more than